Okay, so how many people are new to San Francisco ACM, Bay Area ACM? Well, thank you for coming. Did you find us on Meetup?
Yes.
Okay, sounds good. So the ACM is the Association of Computing Machinery. So when there's computer science journals or conferences or publications, then that goes through the headquarters in New York for computer science around the world. So kind of the professional society, like what IEEE is for electrical engineering, or I'm sure there's accounting organizations for accounting disciplines. We're a local professional chapter. And so we'll have one or two talks a month at this location, and sometimes we'll have other activities. Anybody who's interested in joining, it's just $20 for a year. So tonight's food is sponsored by Neo4j. So there's a couple of Neo4j people. I guess they're in the back. So, oh, yep, and here. So we can thank Neo4j for the food sponsorship. We have our upcoming talks on meetup.com under SFBay ACM. And we have and there's about 13,000 members that have come to some of our meetups at one time or another. So it's a good sized meetup. We have at least 180 past talks of our more recent talks on our YouTube channel, since we've been going since 57. Not all of that on Meetup or YouTube, but as a chapter, we've been going that long. And we support talks on general computing, and I tend to invite speakers for the data science SIG or AI stuff. And so we have a couple of sponsors to thank. One is this location, VRP, Valley Research Park. So they're kind of like an incubator if you want to rent cubes for your small business as a startup. A lot of these tend to be more in biotech, but they have a variety of options. There's also RXM, Cloud Native and AI Training and Consulting. They do training and certifications. Like if you wanted somebody to go to your company and teach a group of people for a week-long class on some kind of specialized cloud topic, so they can do that. Front Egg is also a sponsor, so they've been providing out-of-the-box low-code identity platform. And then C-Cube, that's a company I work for, so I'm the chief of data science there. So we've got a couple of GenAI products we've been developing over the last year. IntelliConnect to chat with your data, RAG, but not yet GraphRAG. Maybe I'll work on that. And Guardians, so guardrails to protect and implement policies. So we're a small startup, haven't been funded by VCs yet, but in 3 years we've grown to 125 people. So we're doing well in our business area. You can do chat in Zoom. Either I or another person will check for questions that we can relay to the speaker. We have some microphones that we can walk around for people in the room because we like to record the questions for the people that watch later on Zoom after the fact. And the only things that get recorded are what gets recorded from my computer. And so if you speak into a microphone and it's loud enough for the room to hear, it's loud enough to get recorded. Otherwise, I have to repeat the question. So right now, are there any announcements of computer science jobs or other upcoming events? Anybody wants to share? I'll go from one side of the room. Raise your hand if you want to make any announcements, jobs, other meetups, other talks. Anybody go to NVIDIA GTC? That was last week. Just me and my closest 30,000 AI friends. So that was good. Also, I'll talk a little bit about one of the other things that we did. I'm wearing this judge badge. And so once a year in March, the ACM local chapter helps judge 1,000 science fair projects. The Synopsis Science Fair has kids from 6th grade to 12th grade. And so we'll review all the projects, give a first, second, third place prizes to both the students and the STEM teacher. And so this year we gave $4,000 to support the students. And so we had about 30 judges for that. Yes.
Yes, I was there, and I was the one with the judge, and I was very, very impressed by the technical level of some of the sports. It was very, very impressive.
Yes. And in fact, I invited some of them to give a talk. I'll label it a student talk just to set expectations, but it is very interesting to see how much of the things that some of the students can do. So we have the topic and the talk description. I'm just kind of locking down the date on that. So as I advance forward in the slides, I'll talk about some of that. But that's a science fair. So we're not just a meetup. You know, we support STEM education. We're a 501c3 nonprofit run by unpaid volunteers. So that's why we appreciate your help and support. Just a general call for volunteers. You can have like a limited way to engage. Sometimes people like to give a talk. Sometimes people like to help with the food delivery. If you're more of a web or social media person, we have roles that can help with that. You know, if you like back-end stuff, there's a member database that could use some help. So there's some variety of things, but we can start off with, you know, small tasks. We have a once a month meeting over Zoom where about a dozen of the main organizing volunteers get together. And so you could join that. You know, you can start off by listening in. If you feel like volunteering or helping out with something, you can. But no stress. Some upcoming talks. So on Monday, April 20th, this is a third Monday. Many times we do a fourth Monday, but the speaker was flying out of the country. So that'll be here. And he's talking about labeled deductive systems for logical validation of LLM output. So Boris has spoken here a couple of times every few years. And he had been an open source contributor to Apache, OpenNLP, and is tends to have very good technical talks, has some good, interesting development. Now for the Science Fair Student Project, this is closing the loop using computer vision to automate PCB e-waste sorting. And so in their school project, they would take an arbitrary board, could be a motherboard or plug-in board, may not be a computer, but just some other system board. And they would heat it up to melt the soldering on a salt hot plate or hot plate with salt on it. So the salt will conduct the heat. They would use a vision thing to go over it and identify the key things, what's useful to pick off, what's not useful, and remove it. Now, what was interesting is it was a $350 device. In the industry, there's a $2,000 device that's like a rock tumbler. You don't get any logic out of that. You just get like materials. So you don't get as much value out of that. Then there's a $20,000 thing that's a picker. So 350 bucks, $20,000. Hey, it sounds like a good idea. Come check it out. Yes, it's a student project, but they had some good thought going into it. We can't share what the winners are of the competition because the award ceremony is at the end of March. But just going around, you know, for the people I was judging, I handed out a few cards. Hey, this is a cool project. I'd like to hear more. So help support students in their STEM education. So for tonight's talk, giving LLMs a map, building smarter GenAI with GraphRAG by Jennifer. So just as an overview, GraphRAG combines knowledge graphs with retrieval-augmented generation to deliver more accurate, context-rich AI applications. She's going to go through some live demos and code, walk through building a solution in Neo4j and Python. She'll use unstructured or structured data as a source. Talk about decisions around schema and chunking. So chunking would be like dividing into the paragraph-sized chunks. Discuss various retrieval strategies, create a conversational agent. And she left a web link, and this is also on the website, so you can find it later. But a good starting point for the code she's discussing is on this GitHub for Neo4j for GraphRAG and Python. A little bit of background in her. She has an MS and CMIS, an avid developer and problem solver that's worked with many business and projects. Oops, sorry for my typo. Expertise in a variety of commercial and open source tools. And there's her LinkedIn profile. So I'll like to stop sharing and I'll turn it over to Jennifer. So Jennifer, I'll go on mute unless there's some questions.
Perfect. Thank you. All right, go ahead and share my screen. Okay. All right, so I already had a great introduction. Thank you so much, Greg, for doing that. We are going to talk about knowledge graphs and generative AI and GraphRAG and creating applications in that space. I've got to make sure I'm on. There we go. Okay, the right tab so I can change my slides. All right, my name's Jennifer Reif. I'm a developer advocate at Neo4j. I'm a Java champion, which just tells you kind of historically where my area of expertise has been. However, like many of us, we're all kind of expanding our expertise in this new AI world that we're in right now. So doing lots of different things now. But really what my day job entails is building things, cool things, systems and applications and technologies and playing around with projects. So writing code and then learning about technology. And then I like to share what I've learned. And that comes through in tech speaking. So events like this or in-person events or all sorts of other things, tech blogging, tech podcasting, tech authorship with another tech book here coming on the near horizon, I guess. I do have hobbies outside of work, but those boil down to the fact that I really like to read. I'm both a mom and a cat mom, which means that all the other hobbies that I have just kind of get tossed into very small slivers of free time that I don't really have much of anymore. Okay. We do have a limited sort of time tonight, but if you think of questions later on down the road, don't hesitate to reach out to me. I know Greg shared my LinkedIn profile there, but I'm also available GitHub and my email address. And I do have a personal blog and website that I have all my social links on there as well. And I have lots of recordings out on YouTube too. So if you're just looking and scrolling through my previous content, I'm available in lots of different places. So feel free to reach out to me and continue the conversation on tech or Neo4j or graphs or data or any of those avenues. Okay. I have often felt like that generative AI in a lot of cases, every time something new comes out, every time we see some really cool demos or this new shiny technology, it feels a little bit magical, right? It's like, wow, how did that happen? That just got phenomenal results. I want to replicate that. And it can really do some amazing and very cool things. And it does work really beautifully for certain things. But often the problem is when we actually try to implement it or when we create our own proof of concept or we try to put this into our own systems and integrate it and all the other things that might be going on in our businesses and our daily lives, then things kind of start to break down in certain places, right? You can end up with things like hallucinated answers or context that just doesn't feel or it feels like it's missing some things. You get disconnected information and a lot of trouble reasoning about different disparate points of data, right? You have a little bit of data coming from here and from there, and you're adding it all together, and it just has a hard time sometimes reasoning through that. So the key here is that large language models are really, really powerful. Generative AI is very powerful, but it doesn't actually know our data. Some of this highly curated knowledge that we have sitting in systems or in people's heads and all sorts of other places just really isn't mapped well. And large language models don't understand that, don't store that. They don't know that information. So often people's first tactic or solution is to go with something like RAG, retrieval-augmented generation. This guides a large language model to specific patterns or certain data sets, terminology, internal language and lingo, particularly curated data sets, et cetera, that we might have optimized or curated so that the large language model knows exactly what we might be talking about or looking for. Now, this is still not a silver bullet. It doesn't solve all the world's problems, but it does do a lot better for a lot of different use cases. How it works is you have embeddings or vectors of data. So you create numeric representations of pretty much any type of data now. And then you're going to do a approximate nearest neighbors, algorithm, where it's going to retrieve some subset of approximate nearest neighbors in vector space to that embedding, to that number, that point, that data point in space. And what it retrieves is things that are semantically similar. So this works really well for like synonym searches, very broad conceptual things, what's relevant and related and similar in this context. For instance, if you're inside an internal company, an internal company will have specific lingo or jargon that they will use and understand certain terms and concepts and the way they relate and how systems interact within that particular company. And if you were just to do a vector search on the general dictionary, you wouldn't retrieve that information. But if you had something that was vectorized internal to that company of all the jargon and the definitions and the way they operate internally, then you could find similar things within that vector space that conceptually are similar without you actually having to be an internal person, right? Now, that does mean that sometimes it's not always the most relevant. So sometimes semantically similar doesn't always mean most relevant, depending on what you're searching. However, this does get us much closer and is better than kind of the single shot fuzzy searches we used to do in database queries. So this is a lot more flexible, a lot more powerful when you're looking for things that are conceptually similar. So it has its strengths and it has its weaknesses. The thing where it's weak is there's some missing context in the relationships. So it doesn't really handle a ton of relationships very well. When you have very complex data, very interconnected data, when your context is coming from the relationships. For instance, you want to understand something, but you want to understand it based on its relationships. When those relationships are super valuable, when the connections mean as much as the thing itself, really. And when you might be dealing with multi-hop questions. For instance, I might want to know how this one thing is connected to this other very distant thing. And in order to do that, it's really hard to trace through that when you're just doing a vector search. How far apart are these two things? How similar are they? And you can't understand why they might be connected, only that they're conceptually similar, right? As an example, which courses would discuss GraphRAG and embeddings? This is a type of question where just traditional vector RAG is going to be a little bit siloed. It's going to kind of have some boundaries to that search, and it's just not going to be able to go too many hops outside of that. Well, now this is where GraphRAG kind of adds a little bit of extra help to this. So you have retrieval-augmented generation, or vector RAG, naive RAG, easy RAG, or however you want to think of it. There's lots of terms floating around there for that. Plus, you're going to use that on a knowledge graph. So instead of just storing the individual chunks of the text or the image or whatever you happen to be creating the embedding for, now you actually have entities and relationships and some kind of structured data to go along with that. So you're not just storing individual siloed chunks, you're storing the connections and the relationships among those chunks and the entities that might be within those. The benefits here are that you're going to get more or just richer context, really. You're going to have those relationships, those connections. That's going to give you that connected information, and it's going to help you better reason about your data. For instance, going back to that idea of how is this one thing related to this other thing, now we can actually see that path in a knowledge graph because it's actually traced out for us. It's connecting those entities together, and we can know how it's getting from one point to the next. All right, so the thing that makes GraphRAG powerful are the relationships. That is really the key. That's the same for graphs in general. It's the same for the strengths of knowledge graph and so many other things when you're just simply looking at graph. The thing that makes it different from everything else are the relationships. GraphRAG is going to add some structure. So you're not just getting the unstructured data pieces, you're getting structured data alongside that, the entities and relationships. We'll actually walk through a case of this here shortly. You're getting some of the context, additional context that you might not get with just a vector search. You're getting related information. Not only do I have this chunk, I might have surrounding chunks, or I might have extracted entities from those chunks. For instance, topics or people or companies or articles or whatever else might be. And now we can reason about that better because we can do the semantic search, the vector search, and we can do an additional traversal to pull connected and related information from those semantically similar things. So the output of that is you can get better answers, more explainable AI, because you know not just the chunk that it's pulling, but the entities that it's pulling that are connected to that. And that gives you more reliable systems as well. All right, so here's what we are going to be doing tonight. We're going to be doing a GraphRAG Python. So we're going to have some source data, and I'll walk through a little bit more of this in just a second. We're going to use some PDFs as well as some structured data as well. And we're going to create a knowledge graph from that. So we're going to chunk up the unstructured data, in our case, the PDFs. We're going to extract the entities and relationships from that. And we're going to create a knowledge graph from that. Then we're going to add in our structured data alongside that as well. And that tonight is in CSV format. So we're just going to take, you could do any type of structured data format. We're just using a CSV example for tonight. We're going to put that all into the graph. And then we need to be able to retrieve that data. So be able to do RAG on that, GraphRAG in our case. But we're going to start with just easy RAG or vector RAG, which is going to be the vector retrieval. We're also going to do hybrid or GraphRAG, which is vector plus a graph retrieval, traversal, or cipher, however you want to term that. And then we're going to do text-to-Cypher as well. So that's where you have a natural language input question, whatever it happens to be, and it's going to try to create a database query, in our case, Cypher query language query from that input. And then that is all going to get sent to the large language model. And then we will also just kind of poke at a conversational agent at the very end using Neo4j, Python, and LangChain. So we're going to walk through this whole process. All right, so let's look at the GraphRAG process. So first off, the first thing that we need to do is we need to set up our data source, our external data source for retrieval augmented generation. So we need to do a little bit of data cleaning. We need to figure out how to store it, and we need to create our embeddings. Now, here's kind of the process for RAG that you see in this screenshot. We have some sort of input. Often in a chatbot case, that might be a question, but it could be lots of other things too, depending on your use case. But you have some sort of input that goes to the application. The application is going to retrieve semantically similar content, do a vector search basically from a external data source. In our case, it's a vector store. It's a Neo4j knowledge graph in our case. It's going to retrieve that relevant information. It's going to pass the original input and the retrieved information to the large language model, which is then going to generate a response or an output or something out the other side. So the process is we're going to have PDF documents. Now, the data set that I'm using tonight is actually my own personal blog, my tech blog from jmhreif.com/blog. And I've extracted all of those blog posts, created PDF renditions of them. I'm actually going to use just the last couple of years worth of blog posts because I actually have quite a few out there, and that it takes a long time to load. So I kind of condensed it down just to keep it short and sweet for tonight. But I'm taking those PDFs, I'm chunking them up into smaller subsections, and then I'm going to create those chunk entities. You might kind of see those here in the middle. So those are the chunks of text. This is the embedding thing that you see on the front of that entity there. And then I'm going to create the original document, so the full blog post metadata, basically the title, when it was published, etc. And then connect all of the chunks of that blog post to the main document entity. So I have a blog post in the light blue, and then all of the chunks from that blog post connected to it. So that starts our unstructured data ingestion. And we are going to, this is just the unstructured piece. And my blog posts range anywhere from 5 to 15 minutes. Most of them are around 10 minutes long. And you can kind of see even just those two blog posts, you can see one of them actually has more chunks. So it probably is a little bit longer of a blog post than the other one is. All right, so the first thing we're going to do is construct the knowledge graph. We're going to have that document chunking. We're going to extract the key entities out of those chunks.
One moment, there's a question in the room.
Sure.
Just wait.
So my question is, does Neo4j make the unstructured data to store in structured way?
Kind of, yes. I'm actually going to show that here in just a second. So I'm doing both, and I'll show the two. It's a little bit easier to see in code, but it will take the unstructured data and chunk it up and leave that. And then we have this entity extraction piece. That's kind of the second step there under the steps on the slide there. And that's where it's going to try to pull the like key concepts and topics and things within that chunk of text. And it's going to extract those into separate entities. You can kind of see those on the data model over here. So we have this document and then the chunk entities here. That's unstructured data. And then everything from here on over in this kind of right portion of the screenshot, those are all structured entities that have been extracted from the unstructured text.
Extracted from Neo4j by Cypher query, right?
No, it's actually, we're using the Neo4j GraphRAG Python package to do the extracting.
Okay.
So it uses a large language model to extract the key entities from that text.
Okay, thanks.
Yeah.
Let me follow.
Okay, perfect. So we'll chunk up the text. It will extract entities, main key entities out of that. And I'll showcase that a little bit more in code so you can actually see how that's working. It'll do relationship extraction as well to understand how these entities might be connected to one another. You can also define a particular schema. So if there's a specific schema you want to extract from those key entities, for instance, you might have particular languages and tools and something else. You can absolutely specify the schema, and I'll show examples of that. And then we're going to add in structured data to this as well. So we can add in some additional metadata and other things we might not get from just the unstructured. Okay, so now I'm going to showcase how this actually works. We're going to switch over to code and open up this first one. Now, the first couple examples here, I'm not actually inserting data into my Neo4j database because I've already loaded my data and I don't want to muddy the waters by creating duplicate data. So it will just print to console the results of the extraction, the nodes and relationships. And then I'll let you know when it's actually like running against the data. So first off, just to start off super, super simple, this is a Python package. It's a Neo4j GraphRAG Python package. It really does two main things. It does a knowledge graph creation or knowledge graph construction, and then it's going to do retrieval. So retrieval-augmented generation, whether that's vector RAG, graph RAG, a combination of the two, et cetera. So those are the two things that the Neo4j GraphRAG Python package does. There's actually a really good Nodes 2025 virtual recording out there on YouTube that talks a little bit more about this package if you're totally unfamiliar with it. But we're just going to cover kind of the main things that it does. If you've done a whole lot of vector database construction or external data source construction, creating whether that's knowledge graphs or curating data in a vector store or some other type of database, some of this will probably look familiar because a lot of it is the entity extraction and entity resolution pieces, and some of the, if you've done some NLP and things like that, some of this might look very familiar. But this is kind of Neo4j's constructed pipeline of the knowledge graph construction piece and the retrieval piece. Okay. Without further ado. All right, so we have a schema extractor here. We are just going to define, we're going to use OpenAI large language model for tonight, but you could pick all sorts of other models as well. We're going to use GPT-4o mini, and we've got a temperature set to 0 because we don't want it to try to make things up or be creative about this process at all. And then we're just going to have a block of text. So I'm not extracting anything from external documents or anything right now. I'm just taking a hard-coded block of text, and I'm just going to see what entities it might create from this text. So it will run the schema extractor from that text, and then it's just going to print that out to console. So I'm going to switch over here to my console and just run this. Step 1. Extract schema. So it's going to take that block of text we defined. It will try to run the schema extraction for that. So here are the node types that it's going to try to create. It'll try to create application, a technology, a service, a tool, and then here's some relationship types as well. So supports, connects to, and then some patterns it should have in here somewhere. Yeah, patterns right here. So it's going to try to create application supports technology. Technology connects to a service provides a tool. So that is the extracted schema that it pulled from just that block of text that I sent it. Now let's go look at the next step. Let's see what we can do next. So now we might want to take one PDF. We're just going to take this one PDF here. I have all the PDFs from several of my blog posts in the data section up here. We're just going to take one of those. And now we've also set up a connection to a Neo4j database. And we're going to create a driver instance so that we have a connection to Neo4j. Now, this particular script is not going to connect to the database and insert data. Again, I'm just printing the results for now because I already have my data set loaded. But I've got one PDF picked out. And now I also have an embedder. So it's going to create the chunks of text, and it's going to create an embedding using the Ada 2 model from OpenAI, which is an older model, but it's very, very low cost. So we're going to try to do that for this single PDF. And this is where the simple KG pipeline comes in. This is from that Neo4j GraphRAG Python package. It uses the large language model. It's going to connect to Neo4j at a particular database because Neo4j supports multi-database as well. Here's the embedding model it's going to use. So that's what we defined up here. And then these are PDFs that it's going to read. So just a little bit of a config there. Okay, and again, I've commented out the actual connection to the database, so it doesn't actually load anything, but it's going to say, hey, it's processing, and it's going to run the PDF loader step, split the PDFs into chunks. Now, right now, it just kind of has a default set of 500 with a chunk overlap of 100. You can absolutely modify this depending on your data set, your entities. You can also use individual text splitting and other sorts of tactics as well with this. But this is just kind of the default. And it's just going to divide the text up into 500 characters with an overlap of 100. and then do an extraction. So it's going to try to extract the entities from that text as well. And then I'm just printing out, hey, print out the nodes, print out the relationship types, and then the total number of nodes and the total number of relationships you would create from this PDF. So now if I run that, and again, this is just printing the results. It's going to do that extraction piece. It's just not going to save anything into my database because I've already got it loaded. So it's going to try to process this single PDF. And it will do a very similar thing where it'll have node types, relationship types, and the patterns that it's going to try to extract from that. What you will end up seeing in the results is that it tries to do a lot. It tries to extract a ton of nodes, a ton of relationships, and ends up with just a really messy data model if you just let it go and do its thing, right? So you can see all these types of entities. It would try to create 126 total nodes, which isn't drastically huge, but kind of a lot for a single blog post, right? Especially if it's about 10 minutes long. One AI node, one action node, 8 configuration nodes, one date node, one file node, and then that's not even the relationships, right? So huge long list. So if you just let the LLM go ham and kind of do its thing, it tries to create a ton of different stuff, and it's just a little overly helpful maybe. So let's see if we can improve this a little bit more. Let's go one step further and narrow this down just a little bit. So same thing here. We've got a connection to Neo4j database. We've got our large language model of choice, our embedder, and a text splitter that we've defined up front. Now we're also going to give it some specific node types that we want it to obey. So say, hey, okay, you had some really wide boundaries and you tried to do a lot of different things with the previous iteration. Let's try to narrow this down a little bit. Let's define or confine you to, what is this, 7 different types of nodes. So now we have some concepts. We have a database, a framework, language, pattern, platform, and tool. Let's just see how it does with this. So we kind of constrict it a little bit and say you can only create entities in these particular types. So it's only going to try to extract things in the text that fit into these types of entities. So same thing here. We've got our pipeline. Yes, absolutely.
From me. So you
Yeah.
have comments on the nshot examples like RAG, vector embeddings, but since they're comments, they're not being used as executable nshot examples. Are
Correct.
you using them as nshot examples elsewhere?
There might be. I don't think I am. Not for this. I
Okay,
think you
that sounds fine.
can, though. I think you could provide sample options and examples. I know you can for some of the other steps. I'm not sure if it works for the
Yeah,
actual
sometimes
entity
clients have
extraction.
sometimes clients have very specific client jargon or acronyms, and it helps to kind of define what's in their terminology
Right.
space.
I think for that, you can set up a like custom prompt or examples, maybe one of the two. There's a configuration, I think, that you should be able to kind of input that in and specify kind of the definitions and things that go along with that.
Okay, thank you.
Yeah. So then we can set up our pipeline. We have the large language model, the connection to the database, the embedder. Now we have these entities. So we're going to constrict it and say, hey, you have entity types of those 7 labels, node labels that we had up here. And then again, our text splitter, and these are PDFs we're dealing with. Again, we're just going to look at a single PDF for now because we're just kind of seeing what it's going to create. And again, I've commented out the actual load of it so it doesn't go to my database. It's going to do the PDF load. It's going to chunk everything up. It's going to build the schema using the node types that we provided to it. It's going to do the extraction piece. And then it's just going to print out, hey, here are the results that we found, the nodes, the relationships, and then again, the total number of nodes and total number of relationships. So with that, let's slip over here and try to do, what was that, step 3, I think it was. And again, it'll take it a couple of minutes. And what we're going to get here is much better on the node types, right? Because it's going to stick to those 7 that we provided it. But it's still going to end up creating quite a few relationships. So we're going to have to kind of narrow down that focus even further because it does obey and does listen to us when we tell it, hey, we only want you to create these 7 node types. But it's still going to try to create a lot of different types of relationships, again, based on the text and what it thinks might be important in that text. And it just basically over indexes often. So you see the relationships are better. It's a shorter list. But we have now our 7 entity types. node types, and it's going to create 65 concepts, 14 frameworks, 42 tools, and then several different types of relationships. Again, this is quite varied. It would be really hard to write text-to-Cypher queries or just try to reason about and look at the data model or try to write Cypher queries, face-to-face against the Neo4j database with all these different types of relationships. So let's narrow that down one step further then and move into the fourth and final step of our knowledge graph extraction. So again, database, we have a little bit of a filter here. This was something that I added in later. It's going to strip out some of the control characters that might be causing problems when it tries to do the split. So that was causing a few little issues when I was working with this. So I ended up having to add this little piece in to kind of take care of that. And then we have our large language model, the embedder, the text splitter. And again, those node types that I defined in the last script. But now I'm also going to define some relationship types, and I'm going to define some patterns. So not only am I telling it, hey, these are the node types and the relationship types I want you to work with, these are how the node and relationship should be connected. These are the patterns you need to create. So a framework builds on a framework uses a database, a framework implements a pattern, a concept uses a framework, etc. So I'm defining a key list of patterns that it should use when it tries to extract some things. And then again, our pipeline definition here, we've got the large language model, the Neo4j connection, the embedding, the entities, relationships, and the potential schema, which is our patterns, are all being defined, are all being added in here in the middle, and then the text splitter and PDFs. And then I also am extracting the title from the PDF so that I can add that as separate metadata. So that's a separate thing. And then the actual blog post metadata. So this is a little bit of a separate thing. So we will be doing our knowledge graph extraction. So that's right here. So it's going to be doing the knowledge graph extraction from the unstructured data. But in this as well, while we're here, we might as well do the structured data piece as well. So I have a CSV file sitting out here of all of my blog posts and just some metadata. So I have the title, I have the actual URL of where it's published, the date, the year, and some tags that go along with the blog post. And I want to add this metadata into the knowledge graph as well, so that now I can look up something and say, hey, where's this blog post published? What's the URL for it? Or, hey, what was the actual date that this was officially published, and so on. I might not have that information in just the PDFs of the text, right? So I want to add that in separately and create that in my knowledge graph. Sorry, I closed my tab there. So that's what I'm doing here. I have, it's grabbing the CSV file, and it's creating a blog post entity with the URL as the key there, setting the title, the date, the year, the tags, splitting those out, and then creating a relationship to the document. So this is our unstructured piece. Remember, we had the document and then the chunks of those documents. That's all the PDF pieces. And we're now connecting the actual blog post via the path. We've basically extracted the slug out so we could pull that based on the slug that's in the PDF text, and then matching that and linking that together. So now we have the blog post from the CSV file and the metadata there connected to the actual document, the PDF metadata, and then the actual chunks of the unstructured data that are segmented out and broken into sections. And then on the other side of that, we have the entities that were extracted from those text chunks. So now we have unstructured and structured data all coming together in the same knowledge graph that we're storing all in one place. And so I won't run because I've already got the data loaded, but I will show you what that looks like when it's done. So let's see here. Where's my tab? One moment. Got to find my tab. There it is. Okay. Oh yeah, this is kind of showcasing stuff. Let's see here. Let's do call.
We are seeing the nodes, but the edge lines seem to be fairly faint.
Yes.
If you want to enlarge.
Yep. 1 second. Okay. So this is the schema. This is all of the different types of entities that are available in the graph. So we have, again, this blog post entity that's from the CSV file.
If you're able to enlarge the font
sure.
or or decrease some of the side stuff so we see more of the graph?
Yep. How does this
So
collapse?
one node is one object or the relationship as well.
A node would be a noun, a proper noun.
Yes. Oh, that did not work. There we go. It's a little better. And okay. Hopefully that's a little bit easier to see. Okay.
I have one question. So
Yes.
when you are, so how do you control the granularity? I mean, like when you are doing the fragmentation, you need to ensure you are not over fragmenting, and also you need to ensure you're not missing a important detail, right? So do you have any control over the granulation? Granularity?
Yeah. Well, I mean, yes, so far as how you define your schema. So again, this kind of goes back to, I mean, anytime you're creating a database, right? When you figure out what entities to put into a database, whether that's a relational database, a document database, a graph database, whatever it is, you kind of need to know somewhat your data set so that you know what entities are going to be most important. What types of questions are you trying to answer? Therefore, what types of entities are you going to be looking for and how do you need to optimize those? So to some degree, you kind of need to know, at least generically and somewhat, what you're looking for. Now, I will say this particular data set kind of surprised me because, again, it's my own tech blog post, right? How hard should that be to dump into a knowledge graph and put that into a nicely curated, neat little box? But actually, and I tend to write relatively synonymous things, right? I have particular areas of focus and things, processes that I like to follow when I extract data or when I query data. I have a typical pattern for I like using this type of application or this tech stack. So I kind of figured it would be relatively uniform, I guess. My writing style, the technologies I use, the things that I write about, etc. But actually, when I started doing this process, I'm like, wow, this is actually way more diverse than I anticipated. So it doesn't all fit into a nice, neat little box, which is kind of interesting and kind of surprising. But I was able, I would like to refine this model even further. I think I could do even better at this. But these were just kind of some of the key entities that I knew I wanted to extract from this. So I know I talk a lot about, particular concepts, right? Whether that's things like architecture patterns or the tech stacks that I might be using or particular platforms I might be deploying to or particular patterns that I might like to follow when I build my applications, etc. And so I knew those things I would want to extract. But then some of the other stuff was like, oh, I guess I have to think a little bit more about this and refine this model even further than what I anticipated. I hope that answers your question. If not, feel free to kind of follow up on that.
No, yeah, that answers. Thank you.
Okay, perfect.
A quick question from Greg. So just
Sure.
to check my understanding, the granularity you go to for the nodes or the edges, maybe downstream, once you start evaluating accuracy and you see where you're wrong, that can drive you to a feedback loop to see if you get to need more granular or less granular in certain areas
Right.
to improve the answers of your sample questions from your user base. And some
Right.
questions, you might have some questions that are simple and some questions that are more complex that have a lower accuracy rate. And
Right.
so that will give you the science behind architecting this. Is that a fair understanding?
Yeah, I feel like you optimize a little bit as you go. And I mean, most of our projects we do that, right? You can start with something that you think is, hey, this looks like it'll work, and sometimes you might be pretty fortunate it'll end up that way. But a lot of times you have to tweak and refine as you go. Hopefully, small things over the long, standing project. But yeah, there is some adjustment I think that has to go into that as you go.
Yeah, and there is some of sitting down with subject matter experts in particular domain as you go. So if you're building an application for the legal team, you actually sit down with a few lawyers to understand their domain.
Yeah.
Hopefully use something like a whiteboard to draw something like what Jennifer is showing, and then use first pass of what Jennifer has done, define nodes and relationships, and keep iterating over it until you catch most of it.
Yeah.
But that's
And
just like
some
a
of
data
it,
science project where you're doing classification or prediction. You build many models, you iterate, you refine,
Yeah.
you tweak the data a little bit.
Yeah, and what our customers do is have a feedback loop where their consumers say, okay, this is good, this is not good. Kind of going back to your
Labeled
science
data.
process of, iterating over an experimentation
Yeah,
on that
okay.
data.
Yeah, and another thing that
Just a minute,
feeds.
there was a question in the back of the room before you.
Just a quick question. When we build this graph, is it a directed graph or is that,
It could be either way.
so you
But-
take how?
No, when defining a graph, it needs to be directed.
Yep.
When you query, you can choose to ignore the direction. In Cypher, you can choose to ignore the direction, but when defining a graph, it has to be directed.
Yep. Yeah. So when you store the data, you have to have a direction specified.
Oh, okay.
When you query or retrieve that data, it can be undirected. It doesn't matter.
Hi, yeah, I have a question about the scalability of.
Greg, you went on mute.
Oh, sorry.
Okay.
Repeat your question.
Yeah, so the question is about the scalability. When we go to a very large scale, like millions and millions of documents,
Yep.
what challenges do you start seeing with the graph structure? I see, like, when we were talking about the granularity and then how do we iterate on that, that can be one challenge. What are your comments on that? And then what are other challenges you see?
Yeah. I mean, we have customers running very, very, very large graphs. So millions, billions, and there might even be a few in the trillions of nodes and relationships now. But the biggest thing there is with graphs, you are hardly ever querying across the entire graph. So when you do some sort of retrieval, it's not like a relational database where you're having to scan the entire table or over the entire index in order to retrieve just the few pieces you need. When you do a graph query, it's pretty localized. It only extracts and pulls the entities that you're looking for and you're working with. So it doesn't mess with it doesn't even touch the millions, billions, whatever other nodes that you don't need in that query. It just extracts the subgraph and the small piece that you need. So over large scale, it actually works very, very well because every time you do a retrieval, it's a relatively small piece of the graph you're extracting.
Okay.
And Soham might be able to provide a little bit more color even yet on that as well.
Yeah, one of the challenges is the additive nature of documents. If you have 1 million documents and you get 1 millionth document, if that has entities outside your originally defined schema, you again need to refactor your model a little bit. Let's say this chunk gets another node. So we have tool, platform, pattern, database, concept, language. Let's say we get one more node, call it maybe language model or something like that. So graph data models or graph schemas are inherently flexible in nature, where you could add more relationships and more nodes as you add to your graph. So that is a challenge we see in enterprises, but it is solvable.
Yep. Thank
I have a
you.
question. The question is the data what we are storing in the Neo4j database. So it is multipass. So at the very beginning, we are storing the data and then we are checking that it has been stored appropriately or not, or maybe this is not the appropriate way of storing that. Then again, we restore and then to and fro method, basically we do apply, and then ultimately we get a appropriate way how the data is getting stored in the backend.
So you would do what we call refactoring the data, where, as Soham mentioned, the data model is flexible, where you can add and remove entities at will, basically. So you could decide, hey, I want to migrate my data instead of having tool type of entity up here. Maybe I want to change this to technology entity. And so I can actually go in and write a query that will take all of the tool entities, create technology entities, and then remove the tool entities. And that's perfectly fine. People do that all the time. Refactoring a graph is actually relatively easy if you need and want to do it.
Great. Yeah, got your point. I have a very basic question. The next basic question is the data what we are storing in the Neo4j. So the behavior of the data should be very specific. I cannot store any type of data, like what actually today we store in the SQL DB. That same data may not be a good choice of storing in the Neo4j, right? For Neo4j purposes, we need different type of data.
Now, yeah, go ahead.
Go ahead.
Not different type of data. So one of the key or one of the fundamentals of a graph database is that graph databases are optimized for consumption, not for storage.
Awesome. Yeah.
Right? Yeah. So if you're storing a lot of aggregations in a graph database, that's not a good use of graph.
Yep.
So graphs are optimized for traversals, right? You see 1 hop, 2 hop, 3 hop, 4 hop. So you want to make sure your data has some relationships in it. If you're just storing numbers, that's not the best use of graph database.
But think if you had a column of a million records with 1,000 categories, those 1,000 categories could be candidates for nodes.
Yeah.
And then the relationship between across a record would be the relationship between, one column and another column is another way to think about it.
Yeah, as an example, just this blog post entity right here. So this was the piece.
Gray sweatshirt had a question.
Go ahead, Jennifer.
Okay, just this blog post entity right here, that's just from the structured data. That's the CSV metadata information that we stored. I could absolutely just store blog posts and the metadata for that and leave it as separate entities. In fact, it would look like this right here. But there is no value of storing this data in Neo4j. A relational database is probably going to be faster or as fast to just retrieve individual entities. Where graph databases really excel is when you want to figure out what frameworks were mentioned in a particular blog post. Because now I'm having to hop through the document, the chunk, all these other entities before I get to the framework. And that is really well suited to a graph.
One last question for now, and then maybe we'll get back to the speaker, but just go ahead.
We've seen graph that has like millions of clusters of dots and not visualize it. Is there a common way of documenting your data architecture so anybody coming from outside will be easily understand the relationships at a large scale?
Okay, so the question is, for a graph with millions of nodes and relationships and clusters, it's hard to visualize it. The question is around any application to
if a new person comes in,
Yeah.
how do they learn about the data structure?
How do they learn about schema, Jennifer?
Yeah. There's a couple of different approaches there, I think, and maybe Soham can add to this as well. A couple of different ways you could do it. The first would be perhaps to look at your entity types in like groups or communities. So you could do something like an algorithm that will extract kind of somewhat related subsections. So for instance, let's say you have a organizational knowledge graph. And across the organization, you might have subgraphs that pertain to accounting or to HR or to your IT department or whatever it might be. And you could segment off those subgraphs and kind of coordinate them and say, okay, these all types of entities and this sub schema basically is your HR department graph. And this is your IT department graph. And this is your accounting department graph. And so then you can drill down and say, okay, I really want to look at the HR department graph and kind of drill down into that. Okay, these are the entities they're working with. These are the, employees and the employee information and the leave policies and all other types of things that might be involved in that. So you could kind of figure out the granularity you want to look at that and then just kind of use the almost like a visualization tool to kind of help you make sense of those very complex graphs that might be kind of underneath, but you can abstract that a little bit. I don't know, Soham, if you have other thoughts on that as well.
It sounds like you could summarize it in an OLAP database that has different hierarchies on different dimensions, and where your hierarchy is different levels of the graph database conceptually.
And it could just be a specific schema visualization too. Neo4j does have tools that allow you to kind of clean up and refine and show different aspects of schema as you need to.
Yeah, just to learn the structure of graph itself, what Jennifer is showing is the graph schema. So you could have millions of blog posts, but your structure will still look the same.
Yeah.
And so there's a command in Neo4j. You can just use one command to visualize a structure like this. Even if you have large clusters, the graph schema still remains more or less the same.
So that was why the earlier step of consolidation was set up to define, okay, I'm only going to have 20 nodes and put everything into one of these 20 nodes or relationships, things like that. That helps simplify.
Right. Otherwise, I would have had way more types of entities here for all the nodes and relationships it would try to create.
Okay. Okay, go ahead with your talk, Jennifer. We had lots of good questions, but I'd like
Yes.
to have you finish your content too, or
Yeah.
work on your content.
So just to kind of show, and we kind of saw it pop up down here. So this is an example of just a piece of the subgraph. So this is the actual data that rolls up into the schema that I showed above. So this is an actual blog post chunk, and you can see it's got some other entities that are coming along with that. Let's see if I can, nope, wrong button. 1 second here. Pull this back out. Okay, so patterns are in the light blue, tools, frameworks in dark purple. Okay, so we can kind of reason about this. So I have some blog post chunks, and you can see a couple of them mention the Quarkus framework. Down here, we've got Spring Data Neo4j framework, and there's other chunks that reference that. There's concepts here in green. There's other types of entities that are all connected to that. Here's, actually the Spring framework in general that's getting referenced. And so it's extracting, there's Maven being referenced as a tool up here. So it's extracting all these different types of entities, and these are the actual entities themselves. These are the real specific data points that we're storing, and then they roll up into, hey, general frameworks and concepts, etc., into the schema above. Okay, with that, yes, we looked at that. So let's jump back into our presentation. Oh, come on. There it is. Okay. All right. Now that we have our knowledge graph stored, we actually need to retrieve things from it, right? So we need to do this kind of middle piece in here, this lookup and retrieve the relevant documents that go into the pipeline for the LLM to use. There are several different retrieval strategies. We're not going to cover all of them tonight, but we've got vector retrieval, which is basically vector RAG, easy RAG, naive RAG, however we want to look at it. And then vector plus Cypher, which is a hybrid or GraphRAG. We've also got text-to-Cypher, where you have a natural language input that gets converted to a database query. Again, because we are using Neo4j, Neo4j uses the Cypher query language. It will take that natural language text and try to convert it into a Cypher query. You have similar things like text-to-SQL and other things as well for other types of languages, but we're going to stick to text-to-Cypher tonight because we're using Neo4j. You can also do things like graph vectors, so where you might want to pull in the network and the relationships of an entity itself. So for instance, if I want to incorporate a celebrity's popularity, the number of connections they might have, I can actually factor that into their vector representation, their embedding. And I can do searches and vector similarity searches. For instance, looking up a main celebrity, I could find out who the other celebrities are based on how well connected they are, right? And that gets incorporated into their vector search, and then you can retrieve those similar entities. You can also do things like graph filtering. So this is where you're taking kind of keyword searches or fuzzy searches or filtering out certain patterns, et cetera, within the graph to do better retrieval as well for things that are more relevant. And then, of course, there's agentic and multi-step approaches where you might use a lot of different tools and a lot of different retrieval strategies in order to pull together the best answer possible. All right, so there's 3 main approaches we will use tonight. First is vector retrieval, which is vector search. Then vector plus Cypher, which is a hybrid or GraphRAG approach. And then we will
One
use
moment, there's an audience question.
Sure.
I want to clarify one point that you mentioned. You mentioned.
Can you speak to the microphone?
It's not. This is not working either.
Is it on over there?
Speak loud. You can speak loud. Yeah, that's fine. I think he was mentioning that we don't store summaries or aggregate data in the graph. But I heard in mentioning that we store like popularity count or something. So
Go ahead. You want to speak?
No, the question. Yeah, the question was, I mentioned earlier that you don't typically store aggregates in a graph, but one of the examples you gave just now was you can store popularity count as a property or as an attribute. So it doesn't apply everywhere, right?
Oh.
By numbers, I mean, don't just store numbers in a graph. So if you just store numbers, it will end up looking like the orange nodes Jennifer was showing. Everything is an island. At that point, there is no value in having a graph.
Yep.
So popularity count as a property Yes, go ahead, Jennifer.
Yes, and I was thinking of it from the perspective of like a data science algorithm. For instance, finding your centrality, your highest centrality entities, and figuring out, okay, or I think it's a node degree, if I remember correctly, if I'm remembering my data science algorithms right, where you're counting the number of incoming relationships or the number of outgoing relationships. So, for instance, somebody like Taylor Swift, I wouldn't just store, hey, she has how many millions of followers. I would say, hey, all these different people follow her social account. So there's a relationship from these other social accounts into her account. I can actually store not the number of connections, but how popular and how many connections she has. I can create that as part of the vector representation. So all of your popular people, all of your extremely popular celebrities would have a similar vector or a semantically similar vector because they all have just huge amounts of followers. It could be the same thing for like somebody who's well educated and maybe not just from one university, but from lots of different educational institutes. Their graph, their relationship, and their connections are going to look different. And if you want to find people that are similarly educated, not just from the number of degrees they have or educational degrees or particular universities they went to, but you want to look at, okay, they've gone to 5 or 6 different types of educational institutes to get their credentials. You could find similarly networked people based on their graph network. Does that make sense?
Yeah. So that concept is called graph embedding, and we can chat later if you want. Yeah.
Yeah.
Good.
Thank you. Yes. Okay. So 3 main approaches: the vector retrieval, vector search, the vector plus cipher, which is also called hybrid retrieval or GraphRAG in our case, because we're using a graph, and then text-to-Cypher, which is going to take a natural language input and try to create a cipher query from that, and then execute that against the database. Then we will also touch on combining these 3 approaches with an agent as well, and using an agent to run these 3 retrieval strategies. All right, so let's look at our retrievers. We're going to go back to some code. I'm going to pull up this vector RAG example. So again, database connection. We have our embedder. Now, the reason we need an embedder for a retriever is we need to create an embedding of the input. In our case, we have a question. We need to create a vector representation of that question. And then it's going to go out to the vector store and say, hey, what is close in vector space to this embedding of the question? And then we have, again, our model here defined. Now, the retrieval query here, it's just the Neo4j GraphRAG Python package will run a vector similarity search. And then the retrieval query here is just retrieving the text and the score. So this is just a vector search. We're not doing any graph traversal or adding any relationships or anything to this. It's just doing the vector search and returning the results from that vector search. We're going to use a vector cipher retriever in our retriever config here. We've got the Neo4j driver, the index that it's going to reference in order to search for the vectors, the embedder that's going to create the embedding of our input, the retrieval query, which is, again, pretty much nothing. It's going to just do the vector search, and then the database that we want to go against, again, because Neo4j supports multi-database. And then it's going to actually run that take that retriever and use that in a GraphRAG config here. And then I have 3 questions that are predefined for us. So it will run through and ask each question, retrieve the results from that, and then show it to us. It's going to print out the question, the answer, and then the context. So the results that it found in the vector store for that. And then it's going to just kind of iterate over those and print those out for us. Okay, let's look at the results of this. So we're going to run this. If I can type, there we go, sort of. And okay, it's much later here. So it's already after 10 o'clock. My hands are cold and my brain maybe isn't working as well. Maybe I'll use that as an excuse, I guess. Okay, so it looks like it did 2 of them so far. So hopefully it'll work on that last one. So here's the first question. What is GraphRAG and why is it useful? So the answer that it came back with is it's a method that enhances the retrieval process by utilizing the relationships between data points in a graph database, combines the strengths of vector similarity search with the connected data of graph databases. Okay, and it goes on. I won't read the whole thing to you. But here's actually the context that it found. So the chunks that it found that were most similar to this input question. And you can see, provide additional context and relationships between the data points, improving the relevance of the retrieved information. Let's see if I can find another point here. Let's see, enhancing the retrieval process, considering the connections and context. GraphRAG combines strengths of vector similarity search. Let's see, lesser known research topics. GraphRAG is shown to improve the accuracy, et cetera, et cetera. Okay, so that's we can see what's actually coming back from the vector search. We can see where it's getting the answer that it generated because these are the chunks that it pulled. Okay, that makes perfect sense. So next question, how does Jennifer describe the benefits of using knowledge graph for AI? I promise I didn't necessarily specify these particular queries. They just happen. Actually, I have some blog post content in there, and they do happen to showcase the uses of vector RAG here very well. So I'm not reinforcing any points necessarily, just these work well for vector RAG. And I have content on my blog post that supports it. All right, so benefits of using knowledge graphs for AI: provide a way to dynamically add data to an LLM's knowledge, improving relevance and accuracy, searchable access to various types of data storage, including databases, text, image, audio, videos, web pages, etc. So here's the context that it pulled. So here are the chunks that it found that were most semantically similar. Again, it's another, again, the same segment we saw earlier on in the previous question. So similar kind of question here. Even a knowledge graph might be able to include all relevant information. This is where agents come into play. Okay, so that was hinting a little bit at agents. Talks a little bit about Neo4j provides the ability to store relationships and standard structured data alongside the unstructured text data and vector embeddings. Let's see. The last segment here, provides searchable access for all types of data. And this is where it pulled that database types, text, images, audio, web pages, etc. So, okay, that's, again, we can see where it's getting that answer. And then what problems does RAG solve? Several problems in AI applications. Again, this is kind of traditional RAG, dynamically add data and information to enhance a large language model's knowledge. Augmentation improves the accuracy and reliability of the generated outputs and allows the system to adapt. Okay, and then again, we can see kind of the chunks. Crucial for harnessing full potential of AI technologies, improves the accuracy and reliability of the generated outputs, etc. All right, so we're seeing where it's getting the information, where it's relevant to the question that we're getting. It's summarizing this really well. The large language model is all of the context that we've provided to it in retrieval augmented generation, and it's providing us a nice answer back. Okay, but that's not GraphRAG. Let's see if we can add another layer to this. Now, this is pretty good for these types of questions, but oftentimes we're looking for maybe specific things, and vector RAG is not so good at handling that. The reason being is it's not looking for specific entities, right? It's doing semantic similarity. That's kind of going back to how I said that the most semantically similar content is not necessarily the most relevant content. So if I were to search for something on Kubernetes, it would pull Kubernetes. It might pull some like Docker stuff, some container stuff. It might pull, hey, you can host Kubernetes on whatever cloud platform. It might pull some cloud platform things. It might pull orchestration or observability things because it's semantically similar, not necessarily relevant. Okay, so depending on the type of question that you're asking, you do need to take that into account. Sometimes vector RAG is an excellent solution, depending on your types of questions, and that's great. But other types of questions, it's just not enough, and it clearly misses the mark on it. So if I were to ask those specific types of questions that we'll show in a second, they wouldn't be as good in the vector RAG scenario. GraphRAG handles those much better because I can actually look for specific entities, specific technologies, because I'm combining the vector similarity search and the connected entities, individual entities that are stored in the graph database itself. So here, very similar path and kind of trajectory and configuration setup that I had previously, but now you can see this retrieval query is much longer. So what I'm pulling now is we have the chunks, because again, that's what it's doing the vector search off of, is the chunk entities. It's grabbing the related document and grabbing the related blog post entities out there. And then it's also grabbing the other like tool and framework and concept entities. So that's kind of this generic E1 variable here that are connected to those chunks. And then it's going to order those and collect all the entities together and then look for another hop out from those individual entities. So for instance, not just the chunk that's connected to the framework, but what are the tools that might be connected to that framework or the concepts that are connected to that framework. So it's going to grab one additional hop there. Apologies. And pull those back. And it's going to grab the path to those entities. So it grabs the first entity name and then the relationship type here and the second entity name. And it's going to return the chunk text, the scoring, the blog title, the URL tags, and then those entities and relationships that we retrieved from the related information from those chunks. Then it'll do the vector cipher retrieval with that big long retrieval query added to the end of it. So that's now doing vector search plus this graph traversal, the additional cipher query tacked onto the end. And then I have 3 questions to find here. Now look specifically, I'm looking at what technologies does Spring AI depend or build on? What frameworks and tools are connected to Neo4j in the knowledge graph? What patterns and concepts are implemented by frameworks in the blogs? So again, much more specific, varied questions that span not just a chunk, but potentially span multiple chunks or entities that were extracted from those chunks. And it's going to do the same thing here, just print the question, the answer, the context that it gets, and then of course separate those by a line. So let's see this in action. Python, this will be step 6. I probably should have cleared my window so we could see kind of the difference a little bit better. There's, I think, 2. And come on, 3rd one. There it goes. Okay. So a lot more context being added in here. Okay, so what technologies does Spring AI depend or build on? Built on top of Spring Framework, depends on various technologies, Java, Neo4j, large language models. Also utilizes tools and utilities for working with GenAI models and architectures such as retrieval-augmented generation. Incorporates components like Spring Data Neo4j, the Neo4j Java driver, and various libraries for handling data and embedding models. So again, it's saying, hey, Spring AI is built on top of Spring Framework. So it's a component of Spring Framework. And it has lots of integrations that potentially could break if like Java or Neo4j makes major updates, or the large language models. For instance, if somebody completely changes their API, you might have an issue in Spring AI as well, right? Something might end up broken. And then here's all the context. So it talks about, the ecosystem here. So that's the vector search text that it's retrieving. And now here are the relationships that it pulls. Here are the entities, the relationships, and then some of the patterns as well that are specified. So Java uses Neo4j Java driver. Java uses APOC. Let's see. Java uses Goodreads AI. Neo4j uses, it's not a great one here. Neo4j uses Quarkus. Neo4j uses MCP. Neo4j uses Olama. There's Spring AI, uses Kubernetes. So it's retrieving all these connected entities to the things that we're looking for that are within that chunk of text. Let's see. Yeah, more content. Again, this is all backing up that same question. So we have the chunk of text here. We have the relationships here. So here's one that's got the token text splitter. I talked about that in one of my blog posts. And let's see here. Yeah, another Quarkus one. Java uses APOC, Java driver there, retrieval-augmented generation, Java uses Cypher, etc. Okay, now asking which frameworks and tools are connected to Neo4j. So it's got Cypher, Spring, GraphRAG, APOC, and OpenAI. So those are the 5 things that were mentioned here. So now we can actually look at the context. So it pulls back the actual chunk, and then it's going to grab the relationships here. Neo4j uses Cypher. Cypher uses Cypher DSL. That's mentioned as well. Yes, question?
Yes. So just to check my understanding on this version, in the back end, we have the embedding model retrieving some chunks, some paragraphs. You have the Neo4j retrieving some relationships, and then that becomes a context window for when the LLM generates the answer, it reads both of those contexts. Is that the case?
Yes, except that the vector search and the graph piece is all being pulled from Neo4j. Because I've stored both the unstructured text, the embeddings, the vector search piece in Neo4j.
Okay.
I've also stored the connections in Neo4j as well.
Okay. So there's an HNSW index you have in the Neo4j to do the embedding retrieval? like fuzzy
Yes.
cleaner's neighbor. Okay.
Yes. Yeah, that's
But
that
you're doing a
chunk
fuzzy-
embedding.
Okay, so you're doing the embedding chunk to provide context, and then the graph relationships, and then that's fed as context into the LLM.
Correct.
And then that reads the question and says, focus on this context, generate
Yep.
the answer.
Yes.
Okay.
Correct.
Check my
Yeah, and we're-
understanding.
Yes.
Yep.
Perfect.
Question from the back?
Sure.
Louder.
In this particular case, to answer all the questions, we just had a static GraphQL or Cypher query, right? But in my mind, I was thinking, depending on the question, you would phrase the Cypher queries differently. So I'm trying to understand, what's special about this Cypher query that works across all queries.
So how do you change a Cypher query from user question to user question to simplify?
Yes. So that is closer to text-to-Cypher, which we will get to in just a second.
Okay. There's
now-
many different modes of doing this combination.
Right. Now, the retrieval query that I have defined is relatively broad. If we looked at it, just to peek at it again here, it's getting the chunks from the vector search, and then it's just grabbing the document and the blog post, and then it's grabbing connected entities. I haven't told it specifically to only look for tools or frameworks. It's pulling all of them right now. Now, I could absolutely narrow it down and tell it, hey, for this type of question, pull this type of thing. But that's more of a text-to-Cypher approach than it is just doing a one-shot retrieval. Right now, this is a single shot. You've got an input. It's going to try to do the best it can with that input against a vector search plus a graph retrieval. And it's not going to have a whole lot of room for customization there. It can't really. It's a single shot to the database and back. Where you really get into a lot of the customization and kind of changing up the query and kind of the structure of the Cypher query and so on is really where you start looking at text-to-Cypher and the agentic approaches, which we'll talk about in a second. So great questions. You guys are all jumping ahead of me, but these are really great questions. All right. So to wrap this up here, I think this is the last question. On the output here, what patterns and concepts are implemented by frameworks in the blog? So it talks about GenAI. It talks, my blogs talk about RAG a lot. I talk a lot about data management, dependency management. In this case, managing the dependencies, bringing in necessary libraries and tools when I build my applications, application architecture, console output and debugging. So I always have a kind of a curl endpoint that I can kind of inspect the data and check for things. And then starter kits and documentations. So that feels very comfortable to me. That looks very good. And then, of course, there's particular instances. GenAI uses RAG, Java uses Quarkus, Java uses APOC. You've got Goodreads AI dataset that I use and reference a lot. There's this is kind of weird. Python uses Spring AI because it doesn't really. I'm not sure where it got that. But there's LangChain reference in there as well, and some other things that it's retrieved. And yeah, lots of data that it comes back with. There's a Neo4j reference to Kubernetes because I have a blog post out there on Kubernetes, and some other things too. So you can see all of this data that's coming back, the connected information, the actual chunks that are getting retrieved, et cetera. So now we have a much broader picture, a much fuller picture, much richer context that we're providing to the large language model for that. Okay. Last but not least, we have our text-to-Cypher. So step 7 here. And here, again, looks very similar so far, but here's where it differs. We add some examples into this. And this is kind of the point that the question that was asked just a minute ago was kind of talking about. So here we want to have some sort of input, probably a question or something, and ask, right? And it's going to try to create a database query, a Cypher query in our case, from that input text. So we want to provide some examples, especially if our domain, our data model, is a little cumbersome or maybe hard to reason about. There's some unusual property names or things that aren't super clear. For instance, instead, find a blog post about topic. What if I asked find an article about a topic? How would it know to look for a blog post? I might need to say, hey, based on this user input, this is the data model we want you to follow. So you can provide some example user inputs and say, based on that, here are the types of queries we want you to construct, and here are the models and things that we want you to follow. So that's really what examples are about. is being very clear to the large language model about when you get this type of question, it might be worded a little interestingly or a little differently. We want you to kind of follow this construct and use these general terms for these types of entities, etc. So here I'm providing some examples. Is there a question?
Speak louder.
So is that similar to like few shot prompt?
Is it like few shot prompting? Yes.
Yes. Yeah. Basically, that's exactly what you're doing. You're just giving it some things to follow off of. And then we're setting up our text-to-Cypher retriever. So we've got the driver, the large language model, the database, the schema, and the examples that we're providing to it as configuration. And then here I have defined a prompt template. So I kind of alluded to this earlier when there was a question asked as well. I can set up the prompt template and say, hey, use the information. If you don't have enough information in the context, just say you don't know. This prevents it from hallucinating or trying to make things up, because sometimes it will try to do that. In fact, I had it do that to me earlier, and I had to go back in and add this prompt specifically so that it would not do that, because it will do that if you don't kind of constrict it and give it some more boundaries, what to do and what not to do. And then, of course, you're setting up your GraphRAG piece with the retriever and the prompt template that we've defined. And again, I have some questions here to find that it's just going to work through and print out the question, the answer, the Cypher query that it generated and ran, and then the context, the information that it got back from that query as well. Okay, so this is our final piece on the retriever side of things. And then we'll look a little bit at agents. So step 7. And hopefully this runs. I find if anything is going to go wrong, it's probably the text-to-Cypher because it's a little bit more finicky. Now, I will say I have had very, very good luck with using the Neo4j MCP server for this. It does text-to-Cypher. It will do read queries, and you can also allow it to do write queries, which I haven't really played with. But it does a pretty good job at the read queries, I have found. So that's a really nice approach to this. I have found that this implementation isn't necessarily quite as reliable. I'm not sure why. I think the MCP server probably has a lot more like configuration and examples and refinements in it to create really good Cypher queries. But this usually does a pretty decent job. Oh, great. It already completed. I just had to scroll down. Sorry about that. Okay. So for instance, how many blog posts were published in 2025? Oh, it doesn't have that information. Oh, but it does. That's interesting because it did actually return 9. So see what I mean about it was doing just fine when I ran this earlier. But yeah, it even tells you the Cypher query that it tried to run, apparently didn't come back. I can test that out actually, see if it just completely failed or what happened there. I'll just switch. Here we go.
Full question.
No, I think it's saying record. 9 records of spot, right?
Yeah.
We did one.
Yeah, so sometimes I've seen LLMs do that, Jennifer.
Yep.
And I just kind of go back to the prompt template and say, don't do this if you have the answer, like scold it almost. And going back to your MCP part, this depends a lot on language models too. Like anyone from Google here? But I have seen, like, quite frankly, enterprises love Claude more because Claude is much better at generating code as of today, I guess.
That's true.
OpenAI and Gemini. Hopefully no one from OpenAI.
Oh, so it's just what we saw.
Yeah.
But isn't code generated by the MCP?
No, here the code is generated by the language model.
Okay. Yep. So this would be OpenAI, and I think I have GPT-4o Mini defined right now. So another model from OpenAI might work better, or as Soham said, Claude might probably would be even better than that. So yeah, it really depends on your model, how you're constructing it, and how you've defined your data model as well, because some data models are easier to reason about than others. So what does Spring AI build on? It builds on the Spring framework. So you can see all the results here. It's got, MCP and chat client and weird stuff that it returned from the query. But the LLM was smart enough to say, hey, Spring AI builds on the Spring framework. So it kind of had enough reference material there that even if the query isn't flawless, the large language model and the query together make sometimes a really great team. And then here, which blog post mentions Spring AI? So we've got Spring AI Starter Kit, build an application with Spring, exploring text-to-Cypher, mention of Spring AI there. And then here's the Cypher query that actually ran for that, and the context, the Cypher or the blog post that it actually pulled. Now notice it did filter out this one. And there specifically is no specific mention to Spring AI in this. I probably just mentioned it in the text somewhere. And so the LLM again has filtered out that response as being, hey, this isn't one that's quite as relevant because we're actually talking about Pinecone and we're not really talking about Spring AI specifically here. So again, some combination. Sometimes you don't want it to filter, sometimes you do, sometimes you want it to aggregate, sometimes you don't. And you kind of have to refine that, either refine your prompt, refine your examples, refine your model, et cetera, to kind of fit those.
Yeah, and
But it does a pretty good job, a single shot.
Yeah, the Cypher query generated is also pretty neat because not only it is doing 3 or 4 hops, it's also taking care of case sensitivity where it's managing
Yes.
to lower e.name contains to lower of Spring AI. So if the document has some weird case sensitivity issues, then it's taking care of that as part of the where clause. It's pretty neat.
Yeah, it did a really good job, even though it wasn't flawless on everything, right? It does a pretty great job out of the gate. And again, more refinement on kind of the developer's end for creating, better examples and maybe using better models and so on would probably even further improve these results. But just out of the gate, single shot, this is pretty good. All right. With that, let's jump back to our slides and look at the next little piece. We're going to take this one step further and we're going to combine all these approaches and use agents. This is where your large language model is going to handle the decision-making process. Your agent is going to be the coordination piece. So it's going to operate between the large language model and the tools, the individual tools that we might have defined. So your application is going to handle the execution. Those are actually the tool calls and the retrieval of the results. Your agent's going to evaluate and say, okay, I ran this tool returned this result. Do I have the problem solved yet? Or excuse me, it's going to pass that to the large language model and figure out between all those things whether it has the full result and is good to go now. So it could call multiple tools, could call a single tool, and then provide the result up to the LLM for it to kind of make the final call on the final output and result. Okay, so what we're going to do is we're going to have it choose the right retriever, the agent. It could query the graph. It'll kind of retrieve all the results and kind of summarize that if it calls multiple tools. And you can use this to answer very complex questions, for instance, because it could call potentially multiple tools in order to solve the question. All right. So with that, we're going to convert everything we've done so far and look at how we put this into an agent. And we do that in the 8th and final step here. Okay. So again, all the configuration looks pretty much the same. The thing that's different here is I'm using GPT-4o Mini again for my text-to-Cypher, but I'm setting specifically the temperature to 0 because I don't want it to hallucinate. I don't want it to try to make things up. I want it to be very adamant and very factual about when it tries to create the Cypher query. And then I have one tool defined for getting the schema. So it's just going to retrieve the database schema from the knowledge graph. So it's going to return the entity types, the nodes and relationships. Then we're going to do the vector plus graph traversal. So this is our hybrid or GraphRAG piece. So it's going to search the blogs, and I've got the tool definition defined up here. I have the retrieval query. So it's grabbing the chunk, the semantically similar chunk. So that's the vector search piece. Then it's going to take from those chunks and grab the documents and the blogs. It's going to grab the entities that are related to those chunks. Notice I haven't gone with the full big, long, grabbing the extra hop of entities and so on. I've kind of condensed it a little bit here. And retrieving the chunk text, the score, the blog title, blog URL, and the connected entities there. So there it's doing the vector cipher retrieval. It's got the chunk embedding. So that's the vector index that it's going to use to search the vectors, the retrieval query that it's going to do to use the graph retrieval piece and return those results. And then the third and final tool, which is our text-to-Cypher tool. Again, a nice long definition up here telling it not to filter results or omit anything. And then again, some examples that we've refined here. And then the text-to-Cypher retriever. Again, I'm using the large language model with the temperature set to 0 for the configuration there. That's why the config variable is different there. The examples and the schema being passed in here, and then returning the results. And then giving it just a generic system prompt, the agent. So saying, hey, you're an assistant for querying a blog knowledge graph. Anytime you want to call the query database, which is that text-to-Cypher tool, always call get schema first so that we make sure it has the best and most relevant, most up-to-date model that it's trying to reference and use. And then we've got kind of basically an input scenario here where it's going to kind of show us the console. We can type in messages and interact, and then it will also tell us the tool that's being called when we ask it particular questions. Okay, so let's actually see this and see how it does. Let's see. Type Python. Whoops. There we go. Okay. So it's going to come up with an input. It's got kind of a nice little, hey, this is a blog knowledge graph agent, ask questions. So let's see. What is the schema? Because I'm curious about what the database schema is. Now, obviously, you probably wouldn't want to do this on like production customer facing systems, right? You wouldn't want them to be able to look at your database that's sitting in the background. So you could lock this down a little bit, but this is nice for demo purposes. All right. So the current schema of the knowledge graph is we have concepts, we have patterns, we have language and platform. These are generic entities that get created with the knowledge graph creation. We could kind of clean those up a little bit if we wanted to. We've got chunks, we've got tools, and then the relationship types. So the next chunk from blog, the builds on, etc. So there are the entity types. Okay, let's ask something else. Let's think about how many blog posts per year. So I've written a lot of blog posts, but I am kind of curious how many I've written an individual year. So you'll notice it'll try to do the query database, but you notice it grabs that get schema tool first. So it's going to make sure it has the latest and greatest schema. So I wrote one post so far in 2026. I've got 9 for 2025 and 11 for 2024. If I worked on back, I'm sure I would have more yet because I wrote a lot more earlier on, especially during the pandemic as well. All right, so now let's look for something a little bit more specific. What do the blog posts say about cloud infrastructure? Because I know I have some blog posts out there on, well, I know I've got one on like Kubernetes, and I've got a couple of mentions of some other things going on out there. So let's kind of just see what it talks about, or see what it finds anyway. So it's calling the search blogs. So that's that vector search plus graph traversal. So that's GraphRAG tool. So here are some blog posts related to cloud infrastructure, Kubernetes and Neo4j. Great. So that was the one I expected to come back, and it did. That's awesome. It also pulled a introduction to RAG. So that's interesting. The blog covers the integration of infrastructure and data APIs to a large language model, explaining how companies create their own integrations through MCP. Okay, cool. Again, the Kubernetes Neo4j, again, because I told it not to filter or aggregate results. So that's why it's specified twice. So it found another section above, but you also do notice that it says, hey, this is a duplicate of one above. It pulled this one, loading data to Pinecone. Again, this is because I was using their cloud database as a service when I was loading data to Pinecone to kind of test out their vector store and just play around with it. And then this one, which I find a little interesting because that's Node's 2024 lineup. But here it's talking about the technical sessions on applications and indicating the relevance of cloud infrastructure in modern software solutions. So that's why it retrieved that. So again, here we did our vector search. We've done our text-to-Cypher, and all I did was provide the input. And the agent determined which tool was best suited to the question that was coming in, tried to execute that tool and retrieve the results, or potentially multiple tools. Again, as we looked at the text-to-Cypher tool, it did the get schema tool first before it called that text-to-Cypher tool, and was able to do that. Okay, go ahead and stop that and switch back over here. All right. So when you are designing your generative AI systems, the way that you design your data definitely matters, as we've seen in lots of different ways, right? Whether you're looking at just vector storage, or you're looking at graph and knowledge graph storage, whether you're looking at how you retrieve that through something like a text-to-Cypher or text to whatever database language, or your particular vector or GraphRAG retrievers, etc. The way you construct your data does matter. Knowledge graphs can add some additional context, answer some questions that a vector search just can't can't reason about because it's not able to do things that are beyond the semantic search, right? Different questions will need different strategies. That's why sometimes that agentic approach is really helpful, because you might not know all of the questions you might get up front, and having lots of different tools that cover those bases of the different types of questions you might get asked can provide a really nice, well-rounded solution. GraphRAG can offer some richer and more accurate AI applications because it does offer all of these different tools from the same data store, the same data source. So that's really nice. If you want to know more, all of the code that I showed tonight is available on that first link. So the code repository, it's all on GitHub. I just made some earlier updates actually because I was tweaking and refining some things. There hopefully will be some more refinements going on in the future as well on that. So keep an eye on that, or feel free to make a copy and update it, tweak it with your data sets and your use cases. If you want to know more about how Neo4j works with retrieval augmented generation, how GraphRAG works, we do have several online free and self-paced courses available on Neo4j Graph Academy. So those are all there at the second link. We do have a virtual AI event upcoming. It's called Nodes AI, entirely free, entirely virtual, has lots of great AI content. Yolande, actually there in the room, is the organizer of most of that, or at least coordinates all the random bits for it. So she knows all about that. It'll be a fabulous event and one I'm really looking forward to. And then
You
if
have a
you
date
just,
for that?
yes, April 15th.
Okay.
Yep, it coincides with Leonard Euler's birthday, so the celebration of just graph theory in general. So we've kind of coincided it with that date. And then if you just generally want to know more about knowledge graph construction or getting started with building your own, I do have an ebook that's available entirely free. That's there at the final bullet, and also the QR code. And I forgot to mention I have the QR code there for Nodes AI too, if anybody just wants to pop that up and go ahead and register. Again, all free, all virtual. So check those out. And again, contact me later on if you think of something down the road. I'm happy to stick around and answer questions. Thank you all so much for staying and asking such phenomenal questions already. This was really fun.
Applause for our speaker. Audience questions? Go ahead and just speak up loudly.
I'm just curious to know, in the industry, how do we, if you develop an application using, how do you do the eval, make sure it's a quality solution gets put in?
So Jennifer, the question is, how do you evaluate the quality of your solution, like accuracy?
Yeah, there are some particular frameworks and tools out there for doing, I would say, more rigorous or more uniform testing, I guess, if you will. Most of the time when I built projects, again, nothing like, super productionized or enterprise based yet. But I just kind of human check them, right? And that's what most of, I feel like, developers will probably do at the outset. When you're initially developing your proof of concept and getting started, you'll kind of just human check. Okay, does this look right? Okay, is this a sanity check kind of thing? And then, of course, as you're moving through it and moving more towards your enterprise and production solutions, you'll probably look for a standard pipeline or tool that will handle a lot more rigorous testing and handle those evaluations. But I also have known people to still add a human loop piece in there where you still have a spot checker every so often that will go in and just sanity check a few individual things and just say, oh, does this look right? Does this look right? Because again, large language models aren't flawless either. So I think it can vary, and it should vary with a lot of different tactics. And another approach too is to have another large language model vet the solution too. So for instance, I could have, with my retrieval augmented generation, I could send the context from the query or from the retrieval, the vector retriever, and the GraphRAG retriever. I could send that to the large language model. It'll generate an answer. But then before that answer comes back to the user, I could send that all to another LLM and say, based, here's the input question, here's the context, here's the LLM's generated answer. Does this look right? And another large language model could evaluate all of that and say, it needs some work, try again. Or it could say, yes, this is a good answer, go ahead and send it to the user.
One tool I've used is RAGAS for RAG assessment. And so that'll have half a dozen measures like context precision, context recall, response relevancy, faithfulness, other things. And so when you're computing text of an answer with text that's ground truth, it's good at doing that. If you're just doing a classification model, then you can have the predicted number versus the accuracy and you just do a subtraction. So this is instant, it's like the text version of subtraction. How close are they in a match?
Yeah, I mean, I heard this judge, but then I start thinking, because this is grounded on custom data. If the judge need to know about, say it's quality data, it needs to know about these.
If you want some kind of accuracy metric, you need some amount of ground truth. Given this question to this document, what's the expected answer?
So you give that document also.
Yeah, so that would be part of a more formal scientific assessment.
Yeah, just like you would have unit tests or integration tests that are constructed by, quality teams, you'll have kind of a similar thing for when you're evaluating large language models too.
Yeah.
We also have some blogs around it. Just Google Neo4j GraphRAG evals.
Okay.
You'll find a few blogs around it.
Are there any people that haven't asked a question yet that would like to ask a question? Go ahead.
More specific.
Louder.
So more specifically on evaluations, how do you evaluate the quality of the schema that's generated, and also about the graph itself, the hallucinations about the graph, if it's actually like which part, if it's hallucinated, how do you evaluate against hallucination of the graph itself? That makes sense.
Did you want that repeated, Jennifer?
I think I caught it. So evaluating the schema and then evaluating the actual, what was that?
Evaluating if there's hallucinations, I think.
Hallucinations. Yeah. Again, I think that's something you would define in your evaluation framework, right? Trying to figure out how far something is. And if something comes back as, hey, this is not close at all, then you have to go back to your context and say, well, what did my context actually return? And there may be formal ways to do this in an evaluation framework. I'm not exactly sure. But you would need to look at that context and figure out, what did it retrieve? Why did it retrieve that? Maybe it's something in the retrieval query. Maybe it's something in the schema. Maybe it's something in the LLM, the way it, generated or used the context. And that also goes into using multiple retrieval strategies. So I mentioned there are lots more retrieval strategies than what we covered here. You could have something like a graph filtering retrieval strategy. So for instance, I could have, you saw kind of the massive amount of text that the GraphRAG retriever pulled. I could actually go through and do an additional filter and say, filter out anything that doesn't specifically mention this term, or surface anything that is, I don't know, related to cloud infrastructure as being higher in the list and more important in that list than other things that might not mention those specific things. So you would do an additional, like a keyword search, basically, or a keyword filter to bubble up the most relevant results to the top. And then that helps, again, just like any human would. If you get too much context, you get too much information coming at you, you likely lose all the stuff in the middle. Well, if that's your most important bit, you've lost your most relevant context in the middle somewhere. So you have to figure out a way to filter and narrow down that search to only the most relevant, and the most relevant needs to be at the top of that list and not somewhere lost in the middle or in the bottom.
Just one last point for
Go
that,
ahead.
Greg. So for schema, evaluating schema, if it's a truly mission critical use case or application that you're working on, use a subject matter expert. Yeah, just.
And some thoughts I had about that to simplify: A/B testing. Schema 1, tweak it. Schema 2, check your accuracy. And you can expand that to ABC testing or a design of experiments. So then you could change your schema. You could change what kind of GraphRAG query structures you do. You could change your embedding model. And so going through all those as a scientific test, you've got a scientific notebook and you've got a hypothesis test. You see what goes to the best accuracy. And then you look at your remaining pool, and then what's in your remaining pool that you haven't solved, then that would be a candidate for training for SFT or other things.
There's a lot more variables involved when you're looking at AI applications, for sure. And it's just really narrowing down, okay, I'm gonna tweak this particular variable and swap it in and out for something else and see if that improves my results. Okay, that didn't do anything. Let's try the next one. And it's kind of a trial and error. Of course, over time you get you might have some particular patterns or things you delve in on, and you naturally gravitate towards certain things for certain use cases, and that's great. But you have to get some experience doing that first before you kind of narrow in on this is exactly what we need to do.
A question I have is in embedding model RAG, to explain the model, I mean, to explain to a user, this is not a hallucination. You display the paragraph it came from for the chunk.
Yeah.
But for a graph query where you have a pattern or a relationship, are you able to show the chunk it came from?
You can have source information that gets retrieved. That's actually one really nice thing about Graph is you can include that metadata on the entity itself, and it could get returned with the chunk text. And so if you had your prompt say, hey, provide the source information, if it's there, it will try to do that. And sometimes naturally, because GraphRAG is a little bit more specific and will show those specific entities because they're connected, it automatically will do some of that. I've had, actually, I just had one of the questions earlier where I asked it which blog post covered which. It actually returned and showed me the slugs, the URLs where it was published, the publish date, and all sorts of other information alongside it because it was retrieved with the graph.
Okay.
So it will naturally be a little bit more descriptive because there's more metadata coming back.
Okay, sounds good.
Your question?
Go ahead, speak up loudly.
How long is it take to make the graph node edge from documents?
Are you talking about one document, a million documents?
Use document like a Bible.
So the question, well, do you have examples of runtime to load data into a graph if it's like millions of documents or very large? I mean, I'm sure
that would really
it depends
depend.
very much on the schema and
Yes.
lots of other things.
Just as an example, my full have written blog posts back to 2018, I think. I'm not exactly sure how many blog posts I have in total. But I have quite a bit. I think the blog post that I loaded tonight was maybe a third or half of my full blog post repository. And the full repository took about an hour. But my schema, I think, is relatively complex. There's a lot of nodes that are connected. There's a lot of interrelationships amongst all of those nodes. So depending on how complex your schema is, how large or small your text chunks might be, what kind of model you're using, how many entities you're extracting, et cetera, et cetera,
What's
et
a
cetera.
rough quantity of data that was in pages of printout or megabytes or
I mean, I can look at it. Hang on.
any measure? Just for a taste test, X converts to an hour.
Yeah, let me just look. Okay, so all of the blog posts, this is what I showed. And then everything else that's in here. Yeah, so I mean, that's maybe half. So I would say the load that I showed tonight, that maybe took, I don't know, 15 minutes, 15, 20 minutes, maybe. So all the data that I showed tonight maybe took me 15, 20 minutes to load earlier. The full data set, I think, was somewhere close to an hour-ish when I loaded it.
Does GPU acceleration or multiprocessor multiple threads help loading?
It could. So depending on which steps could potentially overlap and which can't, you could potentially have faster loading there. But again, it depends on how large your chunks are and how long your embedding dimensions are too. If you have a smaller embedding dimension, 768 dimensions on your embeddings, that might load faster. If you've got a really beefy, you've got a local model running on a really beefy server, that'll probably run much faster than going over an internet connection to a public model.
Yeah, we have also had customers, like you said, run parallel threads specifically for nodes. If they are all the same schema, then just run parallel threads.
And then merge the networks.
100 parallel threads for just creating nodes. And then relationships are a little more nuanced because you don't want to run too many parallel threads.
Yep.
Locking issues in the database and whatnot. But for nodes, definitely you can parallelize. So there are multiple ways to speed it up. Compute, language model optimization, schema optimization. So it goes on and on.
How expensive does it get, in terms of cost? Is it extremely expensive?
So the question is, how expensive does it get in terms of token cost?
Yeah.
I can take the first pass. We have seen with graphs, you actually need lesser tokens because you don't need as big of an embedding as you would if you don't have a graph database. Because embeddings are essentially capturing context, right? But with a graph, you already have context in a structured way, in a schema.
Oh, but you know, I'm not talking about building the graph, just kind of have to tokenize it, like extract it.
Sure. That's a very hard question to answer.
I might suggest,
Yeah.
it's 2 hours later for our speaker.
Yes.
Perhaps we could be kind to her, give her a nice round of applause to send her off. Thank you so much, Jennifer. It was great having you. We'd welcome you back if you ever care to cover further content.
Absolutely. Thank you so much. And all great questions. Thank you all so much.
And there'll be a few other Neo4j people around here to ask questions. And it's great to mingle with each other. Also, so any remote ACM people, you can shut down the recording. I may leave on if anybody wants to ask an individual question to Jennifer, but we can stop the YouTube recording and transmission. Also, if we have leftover food, if you want to put some in like a coffee cup with a lid, you can take some to go, is fine.
Thank you for your time, Jennifer.
Yes,
Absolutely.
thank you.
Thanks for assisting with questions.
Oh, my pleasure. Obviously, I'm interested in this too. It's also my hobby.
So Greg, the tool that you mentioned, is it RAG?
RAG.
Yes, RAGS.